So while a lot of toolchain functionality can be tested using FileCheck string matching, some of the testing require numerical awareness. Two such cases are shown on this slide. The first one on the left concerns the requirement for some 32-bit target to have 64-bit values held into two consecutive registers. So given a 64-bit bitwise AND operation, one might want to check that it translates into two AND instructions, one for each 32-bit parts of the values, and where the register of each values are consecutive. The second case on the right concerns the need for gaps in a structural class memory layout to ensure proper alignment of its fields. One might, for example, want to check that the size of a two structure accounts for those gaps, two consecutive structures. Traditionally, these two cases will be tested by constraining the problem to be able to predict the numerical values. So in the first case, this can be done using relying on the ABI to be able to predict which register are going to be used. In the second case, this can be done by adding some extra alignment constraint to be able to predict part of the address of each of the structures so that we can use proper string matching. Of course, the problem of such an approach is that one will only test a subset of the code path because we have restricted the problem, so we don't deal with the general cases. So now let's look at how this can be tested with the new support for numerical expressions. So the basic syntax is the same as the existing strict substitution, except you have a hash prefix to express that it's a numeric substitution. So in the first example, we'll use the definitions, numerical variable definition on the first AND instruction to be able to set all the register numbers that are used on that instruction. And then on the SQL line, one can express the register values by just doing +1 on these values. So this is quite familiar as the same way as the @line expressions. For the second case, one will need to be able to express that we want the values to be expressed into hex numbers. So there is support for a format specifier to ask for a hex number in this case. Not that this specific part of the feature is not yet committed, but will be sometime soon. It's also possible to unify this, the definition and use into one single expression so that we can check for an expression to be met and set the value, the resulting value into a numeric variable. This is quite useful for diagnostic when you have several diagnostic on the same line. So the first diagnostic will be using @line expression, and we can store it in a variable. And then the second diagnostic, we can use that variable instead of using yet another @line expression. That allows to be able to insert something between the two lines without having to update the check directive. And then finally, the expression actually can be more complex than just a variable and some offset. We can have any number of variable and literals in any orders, and that can be useful in the second example that I gave, where instead of hard coding the size of the structure, it could be from a variable that was set on another check directive before. So future work that is being considered is first to be able to have richer expressions, so be able to have multiplication as well, which will be useful for scaling. And of course, if you do this, you will need to have grouping via parentheses. Another extension being considered is the ability to do relative, instead of checking for equality, checking for relativeness. So whether, for instance, the size of a function is smaller than a given number of bytes, instead of checking for an exact number. That can be useful if the number of bytes will depend on maybe compiler flags or just, yeah. If you have any other suggestion, I wrote a thread on the LLVM Dev mailing list for possible improvement FileCheck, either on the numeric expression support or something else. And if you have any question, please come meet me after the lightning talk. Thank you.